Problem number 11. Back and forth rows. Given a number n, create an n by n matrix in which the integers from 1 to n squared went back and forth along the rows as shown in the examples below. So we have two examples here in which the input is n, which is equal to 3, and we get an answer, an output of a matrix, which is this one, and we can see that it goes from 1 to 9, but we have to go through a path, very specific path here. Then we have an input of n equals 4, and we have the same pattern here. We have a matrix from 1 to 16, but we have to keep going like this. So how we can make this? Since we are starting with a matrix of 1s, now we have to change the values. Since we have a matrix here of n by n, but all the values are 1s, so we have to change that. How we can make this? So this is a traditional way to create a matrix for y equals 1 through n, and then for j equals 1 through n, and then for example just give a counter. So we are defining this counter as 1, and the values of b, which is the matrix, are gonna be equal to that counter, and then the counter change, it updates his value to something like that. If we make this algorithm, we are creating a matrix that goes from 1 to 16 or from 1 to n squared, but we are not making the pattern. Now we have to change that. If the rows are an odd value, then it goes like normal. So we can make this algorithm if the rows are an odd number, but if the rows are even, we have to change that. Since we are saying that the rows are I, then we have to change this depending on the value of I. So if the mod of I and 2 equals to 1, then this happens. So when we say that if I is odd, we are writing this way, like this. Now what happens if that's not the case? We say it the other way. So if the mod of I and 2 equals to 0, we have to say for j equals n through minus 1 through 1. So we are starting from n, and then we are keep going, but with a step of minus 1. So we can start for n4, and then n3, and then n2, and then n1. b is equal to I and y. Counter. So counter keeps going, nothing special for it. So the way counter goes should be something like 1, and then counter becomes 1 plus 1 2, and then 2, and then counter becomes 2 plus 1 3, and that way. When we get to an even row, then we are starting like this. For an even row, we're starting with n as a column, and then we keep going, but with a step of minus 1, minus 1, minus 1, minus 1. Counter keeps going, keep increasing by 1 with each iteration. When we have again an odd row, we just go like normal, 9, 10, 11, 12, and when we get to another even row, then we keep going with this algorithm here. I forgot to make this, and I guess I forgot to put an end here. Let's see if now it's okay. Yeah, that's the answer. Thank you.